Hello everyone, welcome to one more video on calculus. In this video we are going to speak more about critical points and mainly how to find them, and this is one more video in the series of using calculus to find extremum points. These are the notes that were used to make the first video in this series, so I will just shortly go through it as a reminder. We have defined the relative minimum or local and then global minimum, local maximum and global maximum, and then we have introduced the critical values or critical points, which is going to be the subject of the present video. We also have seen the theorem on continuous function, and we have seen the Fermat's theorem, which again is related to the critical points. You can see it is a statement about critical point. So the conclusion of that video was that candidates for relative extrema are the solutions of the equation f prime equals a, and also the points where the first derivative doesn't exist. We'll go into further details, deeper into this now. So today in this video we are going to speak about critical points. So that's the topic now. So a critical point, of course, for the function we have function f of x. So f of x so x equals c is a critical point of f of x if f prime of c equals 0 or f prime of x doesn't exist at x equals c. So in other words, critical points are those points where derivative is equal to 0 or doesn't exist. So those are the critical points. And why are critical points important? Again, because of the Fermat's theorem, and we will come back to use of the Fermat's theorem later on. So have a look what critical points are. So goal here is to actually find critical points. And how do we find them? Well, there are only two types of such points: when f prime of c equals 0 or f prime of x doesn't exist at x equals c. Now we will see how to find them. So let us say example 1, a very simple example. Find critical points of the function f of x equals x 2x squared plus x. So when it's not mentioned where, it means that we have to find on the domain. So answer. So first step, of course, critical points are where, so first derivative equals 0. So that's this is the idea behind that. So always bear in mind this idea. So first derivative equals 0. So let us find the first derivative. F prime of x equals 2x squared plus x prime, which is 4x plus 1. So this is the first step. Second step, we put f prime of x equals 0. But what is f prime? That is 4x plus 1, so 4x plus 1 equals 0. Third step, solve f prime of x equals 0. So that means this, 4x plus 1 equals 0. And then x equals minus 1 over 4. And fourth, find f of that, we can call it c. So c equals minus 1 over 4. Find f of c, which is, if we go back, 2 minus 1 over 4 squared plus 1 over minus 1 over 4, which is 2 over 16 minus 1 over 4. That is 1 over 8 minus 1 over 4, and that is minus 1 over 8. So 1 over 8 minus 2 over 8, which is minus 1 over 8. So the coordinates of the critical point are, so let's say a minus 1 over 4 minus 1 over 8. So this is critical point on the graph. And what does that mean? Now we can interpret. It might be a local or global extremum. An extremum means minimum or maximum. So something might be. So either of these, because if we go back to the Fermat's theorem, it has, if f of x has a relative extrema and f prime is a real number, so this is Fermat's theorem. So for that critical point, f prime of a equals 0. This still doesn't mean that this is an extremum. It just might be. Okay, so that means it is candidate. So what we do with this concept here, for what? For this, okay, for local or global extremum. So we still don't know. There are additional things that we have to check to know whether it is. But it is a critical point and it is a candidate. So we can write that down here. Critical point is the candidate for local or global extremum. So it is a candidate. Okay. So have a look. Candidate. Wonderful. And these are the usual steps that we are going to use when we want to find the critical points. Okay, let us see one more example. Example 2. Find critical points of the function f of t equals 5t e to the power t squared plus 12. Okay. You can pause the video and try, and I will give the answer. Again, the first step is to find f prime of t, which is 5t. That is 5t prime plus okay, we revise here some derivatives, so that is 5 well, so composite function is 5 2t, and that is 5 is 12 plus 10t squared e t squared plus. Okay, in order to make it just a bit more interesting, I will put here a minus. Sorry for that. Not here. I will put here, so minus, so minus, then here will be, so we can put here as minus, everywhere where you see the square should be minus. Okay. So it will be minus 10 here, sorry for that, just to make things working better. And then we can put in front of the brackets and this. Okay. So this is the derivative. Second step is f prime of t equals 0. That means e minus t squared plus 12, 5 minus 10t squared equals 0. Now we want to solve. Here you can see this is, as you know, always different from 0, because the function e to the power x is always different from 0. Therefore, this has to be equal to 0. So 5 minus 10t squared equals 0. T squared equals 1/2. So t equals plus minus square root 2 over 2. So we have two critical points. T1 is square root 2 over 2 and T2 is minus square root 2 over 2. And you can do as an exercise, find A and find B. So here is square root 2 over 2, here is something, the value, and those will be the critical values of the function, or critical points, and the critical values are so these two are critical values, and these are critical, as just a terminological difference points. Okay. So that is how we find critical values and critical points of the functions. Thank you for watching, and I will see you in next video.